Are you planning to upgrade home network and looking for a new router or mesh network system? Have you just got a new router? Increased speed from internet provider? Maybe you've already come across some tests online using iPerf, but you want to see more familiar speed test comparison. Today, I have compared how fast Wi-Fi 6 is or should be when compared to Wi-Fi 5 using internet speed test. In the past, Wi-Fi versions were named using technical coding like 802.11ac. This coding system has now changed to simple and intuitive numbering system. The most prevalent Wi-Fi technology released back in 2014 is 802.11ac, which is now named Wi-Fi 5. The newer protocol 802.11ax is called Wi-Fi 6. So 5 now becomes 6, therefore we should be getting faster speed. Faster speed can mean different things, but most people will look at one device you are using which can transfer more data in the same amount of time as faster speed. Previous generation of Wi-Fi evolution were indeed primarily focusing on this. Although it is true that Wi-Fi 6 standard will also have increased single device throughput, this improvement is no longer a primary benefit of next generation Wi-Fi upgrade. The real change from Wi-Fi 5 to Wi-Fi 6 is for multiple simultaneously connected devices. The first and the foremost, let's ignore marketing talk where it says 3 times faster compared to standard AC 2x2 MIMO. This is because Intel AC 2x2 MIMO is already 2 times faster than standard. So comparing between Intel AC Wi-Fi 5 speed and Intel 2x2 Wi-Fi 6 speed, it's approximately 40% faster is what they are claiming. For a Wi-Fi 6 internet speed test, the minimum requirements to conduct it, one must own Wi-Fi 6 capable router and the client device because you need both of these to have Wi-Fi 6 communication. Also, one needs at least 1 gigabit internet speed, otherwise internet connection itself can be a bottleneck. Fortunately, I now have a setup meeting these requirements, so I have decided to run this test. My current home network setup is fully Wi-Fi 6 capable ASUS AI mesh network with ASUS ROG Rapture GT-AX11000 as a router and 3 nodes each connected via Ethernet backhaul, 1 GT-AX11000 and 2 LT92U for covering 3,800 square foot ranch style old home. For the purpose of today's test, my tests are conducted by connecting devices to a router, so rest of network setup is irrelevant. The ASUS AX11000 router supports Wi-Fi 6 with each 5 GHz band supporting up to 4,800 megabits per second and 2.4 GHz 11,000 megabits per second speeds. All bands are 4x4 MIMO capable. For client devices, I use iPhone 11 Pro, MacBook Pro 15-inch 2016, iPhone 10, and iPad Pro 11-inch from 2018 model. Amongst these 4 devices, iPhone 11 Pro is the only one having Wi-Fi 6 capability. Other 3 are Wi-Fi 5 devices. All are 2x2 MIMO except MacBook Pro 15-inch, which have 3x3 MIMO support. For those of you unfamiliar with MIMO, it stands for multi-input and multiple output. In a big picture, the number represents number of transmit and receive antennas that can directly translate to a speed improvement by number of antennas as multiplication factor when compared to single antenna device. So for instance, 4x4 MIMO device can theoretically transfer 2 times more data than 2x2 MIMO device. This is often a source of confusion to some as actual data transfer speed are by several factors slower than what routers advertised as. But this is the separate topic Basically, MacBook Pro has extra pair of antenna than the other three devices. For the testing, all client devices were placed under 5 foot from the AX11000 router. Although I did not turn off the other devices in home network, including AI mesh nodes, I ensured no one was streaming or playing games during the test. Confirmed internet speed at the router to be approximately 940 megabits per second via Ethernet connected device. For the actual speed test site, I use Xfinity speed test. This is because after testing of a few sites including Ookla, Fast, and Speakeasy, Xfinity was found to be the most accurate for my home. The tests were repeated 3 times, one after another, to minimize speed variation. Here's the result. Let's take a closer look. The theoretical maximum download speed is 1 gigabit per second, as that's what I pay for Xfinity. When I tested speed at the router with Ethernet directly connected to MacBook Pro, I got about 940 megabits per second. So that's the true theoretical maximum. However, my numbers are not even close. So what's going on here? It is well known that Wi-Fi connection has some overheads, and this results in approximately 30 to 50% data inefficiency or speed loss. In fact, Intel's graph accounts 30% speed loss when they were producing this graph. However, 30 to 50% loss are actually based on physical wireless link called PHY formed between the router and device. Using ASUS router control screen, I can actually see both iPhone Pro 11 and MacBook Pro has approximately 1200 megabits per second connection rates. These are actually max speed expected based on the frequency of channel and antenna of the MIMO for given Wi-Fi technology. For iPhone 10 and iPad Pro 11, PHY were 866. Again, expected results. So for 30 to 50% overhead loss for 1200 megabits per second link means my expected speed be between 600 and 800 megabits per second. For 866 link, 433 to 607 megabits per second are expected. So my result perfectly falls between 40 to 50% range. In fact, most suggest 40% reduction is indeed the speed you should expect based on the PHY. So now we know my tests are giving me exactly what we expect. Let's take a close look to see if Wi-Fi 6 is giving actual speed gain. If so, by how much? Since both iPhone 10 and iPhone 11 Pro are 2x2 MIMO, but iPhone 10 uses Wi-Fi 5 and the 11 Pro uses Wi-Fi 6, these two are apple-to-apple comparison. 604 megabits per second on 11 Pro and 457 megabits per second on iPhone 10 are approximately 30% speed gain on 11 Pro compared to iPhone 10. This is not too far from the Intel's claim of a 40% maximum throughput gain. The fastest device here was not the Wi-Fi 6 device, but actually MacBook Pro from 2016. The difference here is that it has 3x3 MIMO even though it's Wi-Fi 5 compared to 2x2 MIMO of Wi-Fi 6. If we compare iPhone 10 and iPad Pro 11-inch, two have relatively similar speed as both utilizes 2x2 MIMO and Wi-Fi 5 standards. When comparing these two devices to MacBook Pro, i.e. difference is 2x2 versus 3x3 MIMO, there's over 40% speed gain. This is exactly what we expect from an additional antenna in the Wi-Fi 5 standard. In fact, this is the real-world bottleneck currently in Wi-Fi once you have 4x4 Wi-Fi 5 Wave 2 or higher router. Most wireless client devices are 2x2 MIMO. If one needs absolutely increasing the single device wireless throughput, increasing number of antenna is the way to go. The reason we don't see 3x3 or 4x4 MIMO in cell phones or tablets are because we don't really need that much of speed on a single device, and battery consumption would be significant for essentially no practical gain. Although 30% gain seems great, this test is not the best reflection of the real-world use case scenario. This is because the most of the time my Wi-Fi use happens not next to the router, but rather a bit away from it. In fact, if you're next to a router or access point, perhaps you might as well connect it to the Ethernet via switch. This is why I conducted the second test using iPhone 11 Pro and iPad Pro 11-inch. Once again, both are 2x2 MIMO devices, with iPhone 11 Pro being Wi-Fi 6 and iPad Pro 11-inch being Wi-Fi 5 device. As you can see, the speed difference here is rather much smaller. 13% increase in speed for Wi-Fi 6 device. Why did this happen? The main reason is related to what's called modulation and coding. Without going into too much detail, when you are close to router with Wi-Fi 6, it can use better modulation technique, 1024 QAM, but at the distance, both Wi-Fi 6 and Wi-Fi 5 uses the same technique, 256 QAM, so the physical link speed difference itself are much smaller. Wi-Fi 6 devices are faster for internet speed, and if you're looking for absolute the best peak max performance, Wi-Fi 6 is a real. However, for the practical single device throughput gain, it is just over 10%. Also, it's really important to understand that to get Wi-Fi 6 benefit, both client and router must be supporting the standard. So in my case, out of 40 plus internet connected devices at home, only one device seeing the benefit. In fact, due to concern about AI mesh stability, I am testing Ubiquiti Unified Access Point, even though their system currently only supports Wi-Fi 5 standard.